में आपको इससे बहुत अच्छा सा रिकॉर्डिंग मिल जाएगा। इधर आप बैठ के बात सुनो, स्क्रीन देखो और जहां जरूरत पड़े स्क्रीनशॉट ले लो बस। ओके, क्योंकि डिस्कशन ही ज्यादा होता रहेगा, क्वेश्चन आंसर भी ज्यादा होता रहेगा। ठीक है, सो जस्ट follow the things whatever we are discussing, and particularly when other people are asking any question, don't think that it is not important for you. Might be you can get some new thing from other people questions, so please concentrate. Now either the equation of motion or in the form of D'Alembert's principle, we can write those equations of equilibrium or equation of motion and we solve it accordingly. And for different classes, we are talking about several problems. Now, last time we were talking about most likely this problem. So this rope has some definite dimension, and when there is some winding up action due to rotation of this disc, so every rotation it shifts to radially outward location. So that radius changes. So naturally you need to consider that rate of change of the radius, and from this we can find out the velocity, acceleration, etc., and solve it. Next we discussed about this problem. It is in static equilibrium. Weight W, the tension passes in static equilibrium position, the tension is W, here the tension W, so this W plus W, that is twice W, and it is under equilibrium. Now find the magnitude of an additional weight Q applied on the left, which will give a downward acceleration A is equal to 0.1 g to the weight W. Neglect friction and inertia of pulleys. So you place this weight and this is the acceleration produced. So you draw these individual diagrams for individual motions. From kinematics we get the relation between the acceleration of this block W and this block twice W, and this simple equation we solve it and you can find out the value of Q. Here was another problem. Three weights were given in 3:2:1, block A, block B, block C. It's not like that at the center of this pulley some force of magnitude, if these are 3W, 2W and 1W, that is W, it's not like that here is some concentrated weight 3W is acting. In that case it will be under static equilibrium, and it's not like this situation. Then when W and twice W are acting, it is under static equilibrium. So instead of that 3W, we are considering a rope passing over this pulley, and 2W and W are attached to the free ends of this rope. So naturally, in this case, if we consider this portion only, the moving pulley, so naturally there will be some relative acceleration of block B and block C with reference to this point D. At the same time, whenever some accelerations are developed here, so tension will not be like that simple self weight of these blocks or in that way. So tension will be different. That tension transmitted through this, that will not be the total weight of this, that is 3W. So there will be some movement, and due to the movement of block A, whether it is downward or upward, there will be some effect on this pulley of center D, and it will be added or subtracted according to the movement of B and C. But what we consider this downward direction as positive direction for measuring the distance, the velocity, the acceleration, etc. And from the simple kinematics, AA and AD, they will be related by this expression. As this total length is concerned from the location X, so XA plus XB that is constant, of course, including this lap length there also, minus this straight line distance from the ceiling to the center of this pulley. So all these things are included in that term constant. So ultimately A plus, it is location D, that is constant. So A plus AD, that is 0, or AA is minus AD, or AD is minus A, whatever we like to present it, you get the relation. Then we come to this detailed diagram about all these. Now all these individual freeway diagrams are combined on the same diagram. So normally we do not do like that, but just to avoid the repetition of all these diagrams, it has been done in that way. So where 3W this is 3W minus twice T, that is 3W divided by G, that is the mass multiplied by acceleration A. We are not talking about the actual or real direction of this acceleration, but as if all the accelerations are positive and it is along this downward direction as it is shown. For block B, twice W minus T is the net unbalanced force downward. So that is mass multiplied by twice W by G multiplied by the corresponding acceleration. And similarly for block C also, net unbalanced force W minus T, that is mass W by G multiplied by the acceleration AC. And from simple kinematic relation, one is this, other is for this part, only this portion, if D is fixed, then AB plus AC is constant. But this AB plus AC, it means with respect to the location D. That means relative acceleration of B with respect to D and relative acceleration of C with respect to D, that summation is 0, or you change the side A of B with respect to D and that acceleration of C with respect to D, those are given that relation in equation 1. Now you simply change this shape of this information. So use this equation and this relation, there you will find AB plus AC is equal to minus twice AD, rather plus twice AD, and that is minus twice AA, that equation 2. And that equation 2, you replace these values of AB from equation 3, 4 and 5. Rather AB, AC and AA. So from equation number 4, we get G divided by twice W multiplied by twice W minus T, that multiplied by, this one, G divided by twice W, take it on the other side, that multiplied by twice W minus T. Then AC is from here. So take this W by G on the left hand side. So G divided by W multiplied by W minus T, and similarly replace the value of AA, of course with some negative sign. This part you have to take a little care, otherwise you will make mistake like me. Okay, so that is minus 2 AA minus 2 multiplied by G divided by 3W multiplied by 3W minus twice T. So simplify it, you get the tension T. T is not required, but we use this T value to get the values of this individual acceleration A, AB, AC, etc. and we get these accelerations. 1/7 of G, 1/17, 5/17 of G, and AC is negative. So ultimately A will be moving downward with some acceleration g by 17, B also will move, but that movement of B will drag C upward, and it is minus 7 g by 17. Okay, so you can take the screenshot of this page for your convenience, so that later on you can check if there is any mistake done by me, or for your convenience just to go through this thing. Okay, now similar kind of problem has been taken up in the next. Here this end is not free like that weight C as it is here. This end has been fixed with the floor. So in that case, what about the kinematic relation? Naturally, you need to take this little care about the movement of this pulley with reference to this fixed base, that is the floor. So neglecting friction and the inertia of the two pulleys, find the acceleration of the block B, assuming these two weights are same, block A and block B. Now please see this diagram. Now whenever we are writing those equations for kinematics, so primary thing is total length of the rope is fixed, it is inextensible. So there are two different ropes. One is this part, and next one is this part. Now this length is constant, this length is also constant. Only thing, the location for A and location for C, these two are variable. Similarly, position of B is variable as well as position of C is also variable. So for the second rope, the length will be this plus this lap length plus this straight part, this one. But one thing is sure, that the distance between the ceiling and the floor, it is fixed. It is L. Okay. Now XA plus XC, it is constant, considering this length plus this constant length plus this constant lap length plus XC minus this length. So including all such things, ultimately we get XA plus XC is constant. Next thing, for the second rope. Now XB minus XC, this is the straight part, plus this constant lap length, plus this variable length, which is L minus XC. Okay, so this part is that additional information what you need to consider compared to the previous one, where there here is no such hanging weight C. Okay, so from this,
Sir, which part is L minus XC?
this one, this is L, this is XC.
Yes, sir.
So this
Sir,
part of the length is L minus XC.
Okay, sir.
This part of the length is XB minus XC. Along with this constant, this will ultimately remain a constant. But this constant, definitely these are different values. Maybe K1, K2, K3, K4, etc. But ultimately, the relation between the position variables for A, B, and this C, they are related in this way. Now, when this L is constant, naturally, XB minus twice XC, that is equal to constant. Okay, so from this we get the acceleration relation, and from the first one, acceleration A and C, and the second one acceleration B and C. Now C is eliminated from these two equations and find the relation between the acceleration of the blocks A and B. So from that kinematic relation, anyway, these clumsy information we must clean from the slate. So regarding this part, that is the second rope length, xb minus xc, the left hand side hanging portion, and L minus xc, the right hand side with respect to the pulley C. It is not as such that conventional free end. This end is free, but length of this portion is increasing with increase or upward movement of this location C, or this length decreases with respect to the downward movement of this center of the pulley C. Okay, so please remember these simple but important parameters. So from these two relations we get acceleration of B and acceleration of A related in this way. AB is equal to minus twice AA. So these are the individual tension for the different parts. For this part, weight WA is acting downward. Here will be some tension. Similarly, that tension is transmitted through this portion that is transmitted here. And from the free body diagram of the pulley C, you'll find the tension on this left hand side of the rope and on the right hand side of the rope. T and T, naturally that same T is carried here on this block B. So from that we can find out the individual equations of motion for block A and block B, not like the previous problem, like there is some block C, not in that way. So what about the relation for block A? Weight of A acting downward minus twice T, the tension upward. We assume net unbalanced force is acting downward. So that is mass WA by G multiplied by acceleration of block A. And from that we write down the expression for T, because we need to eliminate T directly from these first two equations of motion. Then for the second block B, net downward unbalanced force is WB minus T, and that is equal to mass of this block B, WB by G, that is the weight of the block B, WB by G, that multiplied by acceleration of block B. And from here also we write down one more expression for T. Now simply equating the right hand side of both these two equations, we eliminate T and find the relation of this weight of A, weight of B, acceleration of A, acceleration of B, and you transfer the sides for weights on the right hand side and acceleration on the left hand side. We cancel WA, WB and replacing them in terms of W. So only acceleration and G terms are there. So the first part we get this AB divided by G, bring it to the left hand side, minus AA divided by twice G, and that is equal to this W minus half W, and cancelling all these weight terms, we get 1 minus 1 by 2. Okay, but during examination you should not do this simplification by making step jump. Okay, because that step jump will create some confusion for you and for the examiner also. So there should be some clarity how we are getting. So that additional step you should write. But for me, this is no examination. Actually, you are not having that power of directing some marks. Of course, while giving feedback to some maybe some Google form you will get at the end of the semester to give feedback for different subject teachers. There you can give that feedback. So ये टीचर तो थोड़ा बकवास है, वो इतना स्टेप जाम करते थे कि सर हमें कुछ समझ में नहीं आता था. Anyway, I do it intentionally. You take that screenshot and you try to find any mistake if anything has been done there, and you write those things in between the lines there. Okay, so WB minus half WA, and that is WB divided by G multiplied by AB, and that is WA divided by twice G multiplied by AA. We write this expression, replace the value of AA in terms of AB, and find this. And this is ultimately acceleration of block B is twice D divided by 5. And if it has been asked, it is not asked in the question, but if it has been asked to find the acceleration of both the blocks, then what about the acceleration of A? Simply from this expression. So minus half of AB. Okay, but this type of variation in placement of fixed support or placement of the free end, etc., you need to take little more care. Okay. Now, please try many other problems from any book. Regarding any book, I do not have any reservation because I have not written any book. So, उन किताबों को थोड़ा पैसा मिल जाता है, so I don't mind. Or I am not interested to give them some money when you purchase that. Anyway, you follow these instructions and complement or supplement with so many problems. Particularly, you start any book, any chapter, only solved examples first. Please understand those solved examples. Like I am explaining this thing means it is something like if it was in a book, it is something like a printed solution page. So you'll be doing that same thing. Instead of me, you will be your teacher there. ये कभी कभी चेस खेलते हैं आप लोग, तो कुछ लोग बोल रहे थे उस दिन मैग्नस कार्लसन का नाम सुना है, तो डेफिनेटली यू प्ले चेस.
Yes, sir.
I don't know whether it is chess or chess.
Yes.
So
Yes, sir.
कभी कभी आप लोग अकेला भी खेलते हो ना, so आप व्हाइट की तरफ से भी मूव देते हो और ब्लैक की तरफ से भी, but there is some biasness. So if you prefer that white to win, naturally you will give some weak moves for B. But anyway, you have to be impersonal about these things. Okay, so here also, as if you are describing to your student this, you play as a teacher, and at the same time you try to play as a student, that whatever you are communicating to your student, is it reaching you? So anyway, this is not very difficult, as if you are playing that role of a teacher with you yourself. Now there are so many varieties of problem. Okay, nothing to worry of all these things, but only thing, this kinematics part, primarily you need to concentrate to get the acceleration relation for different locations, and this type of special information that you need to consider separately. Okay, now regarding
hello sir.
Yes
sir, I have doubt on the acceleration part. Means sir, expression for distance of B. Means sir, why
distance of B?
Sir, why not we take XB in place of XB minus XC? Means it is the distance from C to B now.
We are considering simple geometrical relation, that is the length of the rope. Okay, so when we consider the length of the rope, एक मिनट होल्ड करना बेटा, I'll do that. So first one is the length of this rope, okay, from A to C. Second one is the rope here is this one, but XB is sorry. XB is this one. And this distance is XC. So what about the length of the rope we are talking to consider? That is this length, which is XB minus XC. This total length from the position of B, subtract position of C, or just one more minute. Okay. So this XB minus, now can you hear me?
Yes, sir.
Okay.
So that's
Yes, sir.
fine. But sir, if we take XB from this C pulley
बेटा,
to the block B.
सुन तेरा जो पहला सवाल था वो क्लियर हो गया?
Sir, my doubt was there. If it means, sir, in this case, XB, then the relation will fine. But sir, if we take XB from C pulley to the B block, then different relation will come. That's why I confused them from where.
C pulley to the B block, it means the relative position of B with respect to C. And it is automatically coming here, XB minus XC. Is it not? In that case, we are holding the pulley C in a fixed position where A is not moving in that way. That means you are applying some opposite acceleration of equal value. Okay. So you think it in some simple manner. The total length of this second rope is fixed. It means at any instance, if XB is the location for B, then XB minus XC is this straight part hanging portion plus this constant plus this length, which is variable in terms of the variation of the position of C, that is constant distance L minus XC, this part. Now you tell me where still confusion lies.
No, sir, whatever you explained, that's clear. But sir,
Yes.
my doubt is if we mean, sir, you take XB from the above of the ceiling to the block B. And sir, my question is if we take XB, that length XB from C pulley to the block B, then different relation will come. Means, sir, where is the wrong in that concept? Means that XB part from where we have to take this.
When we consider the position of B with respect to C, it is automatically included here in this way. This is, you are talking about the distance of B with respect to C at any location when C is here, B is here. In that case also, this length, it is simply the relative length of B with respect to C. That is XB minus XC as a whole. What I was talking, that is separately XB and XC. What you are talking, that is considering both the things as a whole, that is relative position of B with respect to pulley C. C is not fixed.
Yes, sir, I get this. Thank you, sir.
अगर if you do not get it, बाद में ध्यान से थोड़ा सोच लेना. So primary thing is total length of the rope. Okay. From that we get every information, and that is the primary information regarding kinematics. Okay. Now this is already 10:40. So please let me take your attendance. Okay. Just to hold a minute.
Sir,
Yes.
while examination, can
Hmm.
we apply shortcut method like instead of considering all the lengths, if we directly apply the relationship? Sir, will it be fine?
That is like this: XA plus X is equal to constant. Are you asking about that?
No, sir. Sir, I'm asking like I use the method like velocity of pulley. Velocity of pulley is equals to the individual strings velocity whole divided by 2. मतलब summation of individual strings velocity whole divided by 2.
But
If I
where from you get that shortcut relation?
Sir, from here only, here deriving this total length is equals to constant, and then we do it by
This
differentiating.
starting point should be this one at least. Even if you do not go for this length plus this lap length plus this length, that is equal to constant, where XA minus this straight difference is the first part, then this second part, and this third part is XC minus again this straight part. Even if you do not show that thing, at least this thing you have to write, the relation between the position. Then you make the first derivative, relation between the velocity. Then you make the second derivative, relation between the acceleration. Okay, but primary relation that you should start from, this must be at least. If you do not explain all these portions, it is understood that this variable XA and XC are there, the part of the length where the fixed distance of the center of the pulley and the fixed lap length of 180 degree, these are there. Okay, so you should start from this relation.
Okay, sir.
Now, any further question regarding this? Now, in our previous class, we were talking about the another expression, the simple equation of motion F is equal to m multiplied by a. For convenience of some kind of problem, we change that expression. Instead of a, we write it as v dv dx, and we change the sides, give a compact form, integrate it, and integral f dx is equal to integral m v dv, that is half m v square within certain upper limit, lower limit, and for integral f dx within certain range of x, etc. And we call it the total work done and the change in kinetic energy in that manner. But in detail, you have studied in your school general physics, and you know the work energy principle, the conservation of energy, the potential energy, and the kinetic energy. And for conservation of energy for ideal system, you have done so many problems. Now some engineering application. For such problem where you apply work energy principle, it will not be a simple application of that equation. It will be combination of so many things. Maybe this is the same diagram here. Suppose instead of this portion, we write, or rather we replace it by a string. A was as it is, pulley C was like that. One rope is there passing over the pulley, that is also correct. At this free end, weight B is hanging, but the other end, it is not attached to the floor directly in this manner. Something in between is there. The free end of this rope is connected to a spring. Okay. Now, what will be the effect of the weights A and B on this spring? What will be the tension developed in the spring? Or even if we consider about the simple equilibrium, there is no motion. Okay, so for that, normally what we need, that is understand the property of the spring, this part. If this block B moves by certain distance, delta, then there will be naturally the same movement of this top end of the spring by delta. So ultimately, from this location, so there is some increase in the length for the spring. Now, as you know, if you stretch a spring, there will be some force developed. And you have seen so many applications to either to pull a spring or to compress a spring that you have seen. Now, in earlier days, definitely you have seen that spring loaded, even today also, you have seen the spring loaded ballpoint pens.
Yes,
There
sir.
is some locking arrangement from the back side of the or top of the pen. We push it, it generates some compression, and you feel some force, resisting force, when you are pushing that button with your thumb, that as if you are having some back thrust like thing. So it is the property of the spring. When you provide any dislocation or displacement on the spring, either in the form of increasing the length of the spring or decreasing the length of the spring, that is compression, so you will experience some force. Suppose here is that spring simply hanging from the ceiling. Now, if we apply any force at the free end downward, there will be definitely some length change. So this change in length, if we call it delta by the force P due to effect of this applied force P, then what about the relation between P and delta? It varies from spring to spring. in its geometry, in its material property. Do you get my point? Now, can anybody remember your school physics and give me the relation between P and delta? Simply, you just think about this. At this end, at the free end, simply you attach one pen-like thing. And you place there one simple mass having certain weight. Okay. So if that mass is M1, so the force applied P is M1G. We add some more mass there. M2. So what will be the total force acting? Value of P now? Here.
G downward.
It is M1G plus M2G.
Yes, sir.
And as we increase the mass placed on this pen, so definitely you will find for more and more mass placed on this pen, more and more weight will be acting there. So initially it was M1G.
Yes, sir.
Now, sorry, M1G plus M2G. So P increases. So for P increase, delta will also increase. So P versus delta, definitely there is some relation, and that relation depends on the material property of the spring, that material, and the geometry of the spring. So from your common sense, can you tell me the relation between this P versus delta? क्या है? कुछ बता?
P is directly proportional to delta.
P is directly proportional to delta. So it's a straight line like y versus x. Now, whether suppose this is one axis, vertical, here is the horizontal axis. Now, along which axis normally we place the independent variable?
X-axis.
Along x-axis or the horizontal axis. So you can do whichever is the dependent variable along vertical axis or vice versa. So what we can do, either you hold this free end of the spring and pull it downward and measure the delta applied and measure the force you require there to pull it or to generate some displacement delta. So delta will be independent variable, P is the dependent variable, or in this case, P is the independent variable. You go on adding these masses M1, M2, etc. and measure the value of the displacement spring or deformation or increase in length of the spring. But normally you will find these variables are plotted in this way. Delta along this horizontal axis and P here. And normally this P versus delta graph, as you said, it is the directly proportional So this is P versus delta graph, where when there is no force, there is no extension of the spring. So P is 0 when there is no extension of the spring, or delta is 0 when P is 0. You get my point? So physically or experimentally, you need to measure the values of delta for different applied other variable. So suppose it is 0.1, values P1 delta 1, P2 delta 2, P3 delta 3, P4 delta 4, etc. And if we are lucky enough, then we can get this type of relation by simply connecting with a straight line. We'll get that kind of thing, and it is expected that graph will pass through the origin. When P is 0, there is no delta. Okay, but not necessarily you will get all these data points, P1 delta 1, P2 delta 2, etc. Those will be in this simple manner of straight line presentation. Okay, maybe experimentally you find out the P delta, P delta, P delta for different combination for 1, 2, 3, 4, etc. And when you plot it, you get location 1 is here, location 2 is here, this is 3, 4, 5, etc. And when you join these data points, P1 delta 1, P2 delta 2, P3 delta 3, etc., you will get this type of
parabola type.
ओए बेटा चुप हो जा, सब कुछ आपको पैराबोला लगता है ना? It is a curvilinear relation. We have only these points, P1 delta 1, P2 delta 2, P3 delta 3, P4 delta 4, P5 delta 5, etc. You do not know this is a parabola. If we try to fit this general curve for a parabola, you need to find out the constant, the focal distance, etc., etc. But one thing is sure, the graph will always pass through the origin, because when there is no displacement, there is no force required, or when there is no force applied, there is no displacement developed. So this is the primary thing. So normally we use this relation, straight line spring, the spring property, that is for the linear spring, and we consider it for calculation of the work done. Now, what about the work done by any force P for any displacement delta?
1 by 2 kx².
Simply you think about that. When there is some constant force P and we generate a displacement delta, then work done is P delta. But in this case, P is not constant throughout this journey from maximum P to maximum delta. It is varying. Whatever may be the slope, it may be K, it may be M, we will consider it later. But if we consider at any arbitrary instant, the force value is P. This is P. And at that particular position, suppose it is the change in length here, and for this journey, we started from P is equal to 0 to P is P max, and at any intermediate arbitrary location where the force value is P, Then we consider some displacement delta d delta has been produced there due to certain increase in the force P. Okay. Now, this area is very important. This area is the instantaneous work done by that force P, any variable arbitrary intermediate value P, for a very small displacement d delta. It is this infinitesimally small value of work done is P multiplied by d delta, of course, neglecting this part. We consider as if this is a straight line and this part is neglected, this triangle part. So this P multiplied by this d delta, that only. And we can think in some other manner that P is the middle height of that half delta portion and minus half of this triangle area plus half of this triangle area balancing each other, etc. But ultimately it is P multiplied by d delta. So this infinitesimal small work done for any variable instant with the load P producing a small displacement or applying a small displacement d delta. This is the value of the work done. And then what about the total work done? Total work done either from 0 to something, some displacement, or some particular displacement to some particular displacement. Now initially we consider it for 0. Starting from rest, suppose we reach up to P maximum. Integrate that, it will be the total area under this curve. So whether it is a parabola or a curve, any general curve, then this area is this total work done during this application of the variable force P starting from 0 to maximum force, either P max or something like that. Then during this journey, it will take those relation between P and delta. For a simple case, it is a straight line, and we normally mention it in this form. P equal to K delta. Now where K is the spring constant and this spring is linear spring due to this straight line relation for P versus delta. Okay, and what about this area? Half
Work.
base. What about this base? It is delta. What about this height? It is P. And what about this P? P is K delta.
K.
So half K delta square. Or we can write half P delta also. Where P is the maximum value of the force, delta is the maximum value of the displacement. But this force is not playing that role that a constant force P is applied to produce a displacement delta. It is not in that way. So it is increasing corresponding to the displacement gradually starting from 0 to the maximum value. So this half P delta is the work done. The area.
Sir, we